We have an infinite geometric progression, and there is a condition that each term, that means any term we consider, that term is going to be twice the sum of the terms following it. We need to obtain the common ratio. So let's begin. So first we'll have to specify the first term and the common ratio. So let the first term be represented by the letter A in lowercase, and we're also going to define the common ratio. So the common ratio will be defined by the letter R in lowercase as well. Now it's given here that each term is twice the sum of the terms following it. So that means if we consider the first term, this will be equals to twice the second term, the sum of the second term, third term, and the terms following it. And if we consider the second term, that will be equals to twice the third term plus fourth term plus all the terms following it. So we can generalize this idea. So we can say if we consider the nth term, then this will be equals to 2 times the sum of the terms following it. That means the term an plus 1, an plus 2, an plus 3, and so on. This goes all the way up to infinity. Now we know that the nth term of a geometric progression, so that's given by the first term multiplied to the common ratio, and r will be raised to the power of n minus 1. That will be equals to 2 times. So the an plus 1 term can be represented as a times r raised to the power of n plus 1 minus 1. Plus n plus 1 term will become a times r raised to the power of n plus 2 minus 1. Plus the third term will become a times r raised to the power of n plus 3 minus 1. And this goes on. Now we have a times r raised to the power of n minus 1 equals to 2 multiplied a raised to the power of n plus a raised to the power of n plus 1 plus a times r raised to the power of n plus 2 and so on. Now what we'll do, now we'll see that this becomes a geometric series. Here the first term, so this is going to be the first term with the value of a raised to the power of r raised to the power of n. The common ratio is going to be, so let's find out the common ratio. We'll consider a r raised to the power of n plus 1 and divide by a r raised to the power of n. So our common ratio is simply going to be r. Now the sum to infinity of this particular series, that is going to be the first term, which is a times r raised to the power of n divided by 1 minus the common ratio r. So we can now get, on the left hand side we have a r raised to the power of n minus 1, and on the right hand side we have 2 times a r raised to the power of n divided by 1 minus r. So here a and a gets cancelled, r raised to the power of n divided by r, so that will be equals to 2 times r raised to the power of n divided by 1 minus r. We have r raised to the power of n, and this gives us 1 over r equals to 2 over 1 minus r, which will be 2 times r equals to 1 minus r, or 3r equals to 1. So that gives us r value equals to 1 over 3. So this is going to be the common ratio.